The discount rate refers to the interest rate used to determine the present value of future cash flows. Okay, so this timeline is helpful to understand exactly what discount rates actually are. So I first want to contrast it to interest rates because I think that'll help with understanding. So if we invest an initial amount X and at the end of a period we get out Y, and we have a certain interest rate, let's say a nominal interest rate payable pithly, a nominal interest rate per year payable pithly, so then we have P periods, much like the timeline above, where we pay interest, or we receive interest rather, at each of these points in time. So basically what happens is your X grows. So at this point in time, you take X and you add a certain percent of X into your account. And then at this point in time, you take that new balance and you multiply it by your interest rate, in your effective interest rate in that period, and you add it back into your account. So you keep adding interest, and you add that percentage interest at each of those points, and your account grows in value until it's worth Y at the end. Okay, so how does discount rate differ? How do we understand discount rate? So instead of adding at each pithly period in time, what we do is we start at Y, we get given this value Y at a certain future date, and then we are going to calculate X using the discount rate payable pithly or convertible or compounded. Those three words all mean the same thing. So basically what happens is we take this Y, and at this certain point in time, a P period back from Y, we take out a certain amount, a certain percentage of Y. And then at this point in time, 2 P periods back from this future point in time, we take out another fraction of the balance. And we keep doing that until we're left with X. So the pithly effective discount rate is the percentage by which we decrease our account every P period to get back from Y all the way to X. And that would be dP over P. That's the effective discount rate per period. And then obviously dP then must be the nominal discount rate convertible or compounded or payable pithly. And then D over here is the effective discount rate per annum. Okay, so let's move on to a few identities that will be helpful. So if we want to convert from discount rate to interest rate or the other way around, this is a very useful identity to use, and you can use it for effective and nominal interest and discount rates. So we know that 1 minus dP over P to the power of P is a discount factor. So maybe I should have explained over here, how do we calculate Y given X, and how do we calculate X given Y? So the first way, how do we calculate Y given X? So Y is equal to X times by 1 minus D to the power of negative 1. And then obviously X must be equal to Y times by 1 minus D. And then you can replace 1 minus D with 1 minus dP over P to the power of P, and your equation still holds. Okay, so what that effectively means is that if we multiply Y by either of these expressions, then we discount our value Y to become the value of X. Okay. So going back to the identities then, these are discount factors, and that's the way that we equate them. So interest rates, using interest rates to evaluate the discount factor, we have a negative in the exponent. So don't forget that. Okay, then another useful identity is for effective discounted interest rates. We have that D is equal to I over 1 plus I. And if V is our discount factor, 1 plus I to the negative 1, then we have D is equal to 1 minus V, or 1 minus the discount factor. All right, so let's move on to a few examples. So this first example is a conversion example. So what is the discount rate, convertible, compounded, or payable monthly, if the effective discount rate is 10% per annum? Okay, so let's write out our initial formula. So we have 1 minus D is equal to 1 minus dP over P to the power of P. Okay, so what are we given? Well, we're given an effective discount rate. So we know that this is the effective discount rate. So 1 minus 10% here on the left-hand side. And what are we trying to calculate? We're trying to calculate the discount rate payable monthly. Okay, So what is that? That's dp. So what exactly is p? Well, if it's payable monthly, there's 12 months in a year, so p is 12. So we have 1 minus d12 over 12 to the power of 12. Then we solve for d12, so we get d12 is equal to, and 1 minus 10% is 0.9. To get rid of this 12 in the exponent, we raise it to the 1 over 12. We subtract this 1, and then we multiply by negative 12. And the answer that you should get for the discount rate convertible monthly is 10.4899%. Okay, so this next example, we have to calculate the present value of an account that is worth $1,000 in 3 years using a discount rate of 6.5% compounded quarterly. Okay, so present value calculations involving discount rates take the following form. So we have the future value multiplied by 1 minus the nominal discount rate, convertible P3, so that's dp, over p to the power of p times by n, which is the number of years. Okay, so in our current example, p is equal to 4 because there are 4 quarters in the year, and n is equal to 3 because there are 3 years. And then dp will be 6.5%. And our future value is $1,000. So all that we have to do is substitute in and solve. So we get the present value is equal to 1,000 times by 1 minus 0.065, which is the same as 6.5%, over 4 to the power of 4 times by 3. And that should give us the final answer of 821.5177368. But remember, this is currency, so we have $821.52. Okay, and if you were to calculate the future value given this present value, then you would say the future value is equal to 821.5177 with all of these remaining decimals times by 1 minus 0.065 over 4 to the power of negative 12. So the difference here is the negative 12. And that's easy to see because if you were to take this factor across to the other side, it would be in the denominator. And then if you raised it to the numerator, you'd have to make the exponent negative, which was what we've done here. Okay, so I hope you found this video useful and interesting. And if you did, please don't forget to leave it a like and subscribe to my channel. Thank you for watching.